Good morning. Welcome back. Hopefully, you had a nice time away. We're going to start Chapter 8 right away, and I'll be honest, we're going to fly through Chapter 8. It's all about how mountains and volcanoes are formed, which are kind of cool, and it's kind of fun and easy and quick and just to get through. We're planning on getting done with Chapter 8 right before our spring break. We will have the final test on March 19th, so if you want to be proactive, put that into your assignment notebook and on March 19th on Friday, and you could definitely make sure that you are aware and ready to study for that test. So with that being said, let's go over and look at what you're going to add into your assignment notebook right now. So while I'm doing this, pull out your assignment notebook and get ready to write something down.
So you will see that today we are going to take some notes, not a lot, but enough to talk about what folded mountains are and what fault block mountains are. Those are our two types of mountains that we're going to talk about in this section. So when we're done with this lesson today, when you're done taking notes, you should have a very good idea of how a fault block mountain formed and how a folded mountain forms. There are two different types of mountains formed by two different processes at two different boundaries where the plates collide. So you're going to need to know those definitions. They'll be into our notes as well. And then you are going to need to know how the Himalayan mountains formed. We've talked about how they formed in the past. We talked about when Earth's history had one supercontinent called Pangaea. And we talked about at one point how India used to be down towards the South Pole, and India, the continent, moved its way up towards Asia.
And as it moved its way up toward Asia, it ran into Asia. The continent of India ran into the continent of Asia and created currently the tallest mountain range in the world. So you're going to have to know those processes of how that happened. And that's
actually indicated in your book on page 257. There's a whole series of pictures and captions that tell how the mountain range is formed. So make sure you are looking at that as well. Just a general rule, if you want to just open up your book right now and turn to page 253, as we are taking the notes, you'll be able to see that the notes that you are writing down are coming straight from the book. Like I've mentioned this before many times, I read the book and I take the notes as if I were you, and pulling out just the information that I think that's most important. There is lots of information in the book. I don't necessarily put down everything that you need, that the book says, into your notes. Your notes would be horrendously long. So you should be thanking me that I'm not writing down everything in the notes, because you'd be taking notes for 3 days straight on one section. So anyway, with that being said,
like I said, open up page 253. Open up your science notebook. Start a new page. Title it Chapter 8. Chapter 8, Mountains and Volcanoes. Now, when you look at mountains and volcanoes, we have them all over the world. We have a mountain range on our west coast, the Rocky Mountains. We have a mountain range on our east coast, the Appalachian Mountains. There's a mountain range going down the west coast of South America called the Andes Mountains. We have the Himalayan Mountains between India and China. We have the Alps in Europe. We have the Ural Mountains in Russia. There are mountain ranges all over the place, and there are volcanoes all over the place. And we'll talk more about that in section 8.3. But all of these structures were created by those processes that we've been talking about. Tectonic plates moving, tectonic plates running into each other, tectonic plates pulling apart from each other, sliding past each other. All of these geological processes are creating these mountains and are continuing to create these mountains and will continue forever. There's a term that I don't know if I've used it yet. I can't remember, but it's called uniformitarianism. It is a huge word. You could look it up, uniformitarianism. Basically, all it just means is the processes that have happened in the past to shape the earth are happening in the present to shape the earth and will continue to happen in the future to shape the earth. It's a pretty interesting concept with a huge word. So if you ever want to impress somebody with a very long word, use that one, uniformitarianism. So let's still take a look at our notes, and when we start taking notes, underlined words, highlighted words, those are the things that you probably should be putting into your notes. So
let's take a look. All right, Chapter 8, Mountains and Volcanoes. That movement of the rocks, movement of those tectonic plates builds mountains. We talked about that already. They happen along tectonic plate boundaries. If you were to take a map of the world where all the mountains are, and you were to overlay that map over where the tectonic plate boundaries are, almost every mountain range or almost every mountain or volcano would be found near one of those plate boundaries. Almost every. There are some that are not. But majority of them are found near those tectonic plate boundaries. There are some terms you need to know. One of them is something called a mountain range, and that's number 1 right there on your in your notes in section B. Mountain ranges. They're simply a long line of mountains, that were formed at the same time and by the same process. There are mountain ranges along the west coast of the United States. You have, I believe, the Cascades. You have the Sierra Madres. You have the Sierra Nevadas. Those mountain ranges were all formed at different times from each other, but that whole mountain range, the Cascades or the Sierra Nevadas or the Sierra Madres, they were formed individually at the same time by the same process. If you want to take a look at this image right here, these are mountain ranges. Definition: a long line of mountains. You have this line of mountains right here. You have this line of mountains right here. You have this line of mountains right here. And there are different lines of mountains in between. I only showcased a couple of them. Now, these are mountain ranges. The process that was happening to create these was the same process to create this whole mountain. But the process to create these was a different process. You can see that these are further inland. These were created by an earlier collision of continental crust and oceanic crust, whereas these are a newer collision. So mountain ranges are just long lines of mountains. Now, if you get enough mountain ranges together, we get to our next vocabulary word, which is a mountain belt. A mountain belt is just simply a bunch of mountain ranges that are close together. That's as simple as that. Most mountain belts are located along tectonic plate boundaries. Now, I'm going to probably upset you, but this one right here here are mountain belts. This is all a mountain belt. You have all these ranges right here, boom, 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 boom. They are all kind of together. So this would be considered a mountain belt because it just is a collection of mountain ranges put together. So maybe that gives you a better visual of what that is. Now, when I said that they formed near tectonic plate boundaries, the tectonic plate boundary that they are near is the one between North America and the Pacific plate. Right now, those plates are sliding past each other. But at one point, they were not sliding past each other. They were converging with each other. They were colliding with each other. And that collision does cause the rocks to bend and fold and push up. And we're going to use some of those terms and some of that description to describe how folded mountains actually occur. Now, there is a way that you can tell if something is a young mountain or an old mountain. So, young mountains are rugged. Make sure you kind of jot that down. Old mountains, they look, or should be young mountains, are jagged. They're pointy. And with that being said, I'm trying to find something here. But I am not being very successful. My keyboard has decided to die on me, so I can't look this up for you, but you sure can. The young mountains, by rugged I mean that they're taller. They've got sharper peaks. They look like the typical mountain when you see it in a movie or in pictures. They usually have like the pointy type of peaks, or just the jagged parts. They tend to be steeper. They tend to be a steeper mountain versus a flatter mountain. That's what younger mountains look like. Now, older mountains, they tend to be rounded. And I think you might be able to guess why they've been rounded. But if they are older, they just have been around longer. They've been exposed to water and wind and weather. They've been weathered down. They've been broken down by time. Our mountains on the east coast of the United States, the Appalachian Mountains, they are an older mountain range. They've been around for a very long time, and they look it. They're rounded. They've got trees growing on them. They're shorter, just because those top layers have been broken down, have been worn away and washed away towards the shore or downhill. So when you look at a picture of a mountain, if you see it have pointy peaks, that's a young mountain. If you see it have a rounded top, it's an older mountain. So here's the definition you need to know. Here's another definition you need to know. You need to know what a folded mountain is. And if you take some moments here and copy that down, I appreciate it. A folded mountain is a mountain that forms as continental crust crumples, folds, or bends into folds. So take a moment, get that copied down. If you need to pause the video, go ahead. Folded mountains are like the mountains that you see in the Rocky Mountains. Folded mountains are like the mountains that you see in the Himalayas. So as the continental crust is running into something, or an oceanic crust is running into something, some of the materials get pushed down, most of it gets pushed up, which is how the mountain is formed. This set of descriptions here, there's only a couple things that I want to have you pull out of this. Folded mountains form as oceanic plates sink under the edge of the continent or as continents themselves collide. So the Rocky Mountains are formed because oceanic crust runs into the continental crust and kind of pushes the continental crust up, but the oceanic crust slips down. The second part of that one with the continents colliding, that's more like the Himalayan mountains, where India, remember, moved from being towards our South Pole, moved up and ran into Asia, and is still continuing to run into Asia and still pushing that mountain range up and up and up. Now, volcanoes can form where those areas are happening, those are the subduction zones. That's why along the west coast of the United States, there are several volcanoes, some active, some not active. We have Mount Hood, we have Mount Rainier up, I believe, in Alaska. We have Mount St. Helens. All of these volcanoes were formed by that process of that subduction. Now, on page 257 in your book, it does go through the steps. Steps 1, 2, 3, 4, 5 on these notes here. I'm not having you write it all down, but steps 1, 2, 3, 4, 5 are on page 256, 257, because it explains how the Himalayan mountains were formed. And you're going to have a pretty good understanding of that. So when we're done here, after you get done with your work, maybe go back look on page 257, please, and you'll get a better idea of how things formed. Now, with that being said, there's another type of fault, or excuse me, another type of mountain called a fault block mountain. Folded mountains are because of collisions, convergent boundaries. Fault block mountains are from normal faults. Normal faults, if you remember, and I hope you do, normal faults are when the plates or the crust is being pulled apart, when it's being stretched. So as it's being stretched, the rock does break, and it breaks into blocks. And then as these blocks, or as the crust stretches and makes blocks, then it stretches again and makes another block. These blocks start to build up, and you get a fault block mountain. So two definitions that you need to get down are 1 and 4 on this slide. So I'll give you about a minute or so to jot this down. The main thing you have to get out of number 1 is that it happens near a normal fault. So you may not have to write down word for word, but you should write down fault block mountains form along normal faults. I mean, that would be the bare minimum that you could put down. And then number 4, fault block mountains form earthquake by earthquake. That earthquake is that rock splitting at that normal fault, creating that block. And as stress builds up, it's released again, and then that makes another block, and then the stress builds up, and then it's released, and that's another earthquake, and that makes another block. And it happens as the crusts are being stretched. So make sure you jot that down. If you need to pause it, go ahead and pause it. Then we get to our review questions. And there are more, there's 5 in your book, but these are on page 260. you don't have to do all 5. You have to just do the first 3. The first 3 that I have put in red blocks here. So the first question says, how is the formation of mountain belts related to tectonic plate boundaries? So basically, we talked about folded mountains, where continental crust is running into continental crust near that tectonic plate boundaries, where one tectonic plate is running into another, either continental and continental or oceanic and continental. And then we talked about fault block mountains happening near normal faults, which is, again, near tectonic plate boundaries that are pulling apart from each other. So make sure in your answer for number 1 you explain that somehow, that with convergent boundaries and divergent boundaries, and where mountains are formed normally, that's included in there. And then question number 2 and 3 are basically just tell what folded mountains are and how they form, tell what fault block mountains are and how they are formed. The other questions here, there is a range of mountains called the Ural Mountains. They're kind of right on the border between, or sort of near the border between Europe and Asia. And these mountains are rounded and shorter because they're not near a tectonic plate boundary. There was once a tectonic plate boundary there. There must have been in that area, but as Pangaea kind of split up and continents kind of ran into each other to create Pangaea before, there must have been a tectonic plate boundary there. Now they're rounded and shorter because of time and weathering. Now the question here is, how can a mountain continue to be pushed up and not get any taller? And it's really as simple as it's weathering down, breaking down as fast as it's getting pushed up. So a mountain range may rise 6 inches in a year, but over that year it may also weather away the top 6 inches of the mountain. So I did forget to point out one thing. I don't know if I said it or not. Maybe I did, maybe I didn't. There was something really... Oh, I forgot to scroll down one more. There's this, you probably should add to your notes as well. I didn't scroll down far enough on this slide, but remnants of the seafloor can be found in mountains. We have found this, that as people are exploring Mount Everest, they are finding fossils of seashells near the top of Mount Everest. And there's a very simple reason why, is that top of the mountain used to be at the bottom of an ocean. At the bottom of that tectonic plate of India, there used to be that rock. And then as that ocean, India ran into Asia, it pushed that oceanic crust up to the top. So it's a really unique and interesting discoveries that we're finding, is that we can find sea creature fossils towards the top of the mountain, and they've concluded that that's the case is because it was at one point at the bottom of the ocean. So with that being said, make sure you just add that in there. I know it was kind of late and I screwed that up. But so today what I'm going to ask you to do is the code word for today. When you put this on your assignment that you're turning in today, the 1, 2, and 3 on page 260, the code word is mountain. So just type in the word mountain as the code word in your comment box, and when you get those 3 questions done, make sure you just turn it in. So we'll correct these the next time that we meet. Have a good rest of your day.